Hello everyone, my name is Kos Knutson. I am the CEO and founder of Isolate Extraction Systems Inc., also I.E.S. First I want to thank you all for attending my speaker session here in Athens. It's a pleasure to be here and talk about CO2 extraction of hemp and cannabis. Before we get started, I'd like to give you a little background on myself as well as my company, I.E.S. I am a mechanical engineer by trade. I'm from Boulder, Colorado. I have a tremendous passion for fabrication, design, and entrepreneurship. I've really enjoyed building this business over the last 6 years. Prior to starting this business in late 2012, I spent about 4 years in the very early stages of the cannabis industry in Colorado, just as at its infancy. And I worked with my brother at the time, and we were building a infused product brand, and it's still running today. My brother is actually the CEO of that company. That's called Keef Cola is the main brand. It's an infused carbonated beverage. Had a lot of fun building that, and in the process of that I discovered something that I enjoy more, and that's building equipment and teaching people how to use the equipment and how to be successful using the equipment. In late 2012, after thinking about it for quite a while and seeing an opportunity to use my assets and skills, I decided to invest pretty much everything I had and max out 5 credit cards, and it paid off. Here we are 6 years later, sitting in Athens, Greece, with the opportunity to speak to you all. Over the past 6 years, we've gone from producing lab scale concept machines to now producing large scale machines capable of processing hundreds of acres per year, which is very exciting for us and still just the beginning of the development of the technology. As you see on there, you see Adam Knight, COO. He's attending that with us, as well as our European representative, Morten Krug, who's been tremendous at manning the booth upstairs and collecting as much information as possible to help everybody out, and as this gets rolled out in Greece, which is very exciting for us. So now on to CO2 extraction. So why CO2 compared to ethanol, butane, propane, hexane, methane, whatever you want to extract with. From the beginning, I knew that CO2 was ideal and the most versatile solvent. There were some hurdles in the beginning in that there was not very good market reception of it. Some of the equipment that had been placed into the industry was slow and cumbersome and didn't really have the best parameter controls and consistency to create the products that I knew CO2 could do. So for the first couple years, I spent time really perfecting that, and one of our primary focuses as well was automation. So there are many different advantages to using CO2 as a solvent. Number one, in my opinion, is toxicity. Although the other solvents in low quantities are non-toxic as well, you have zero chance for that with CO2. It's expelled naturally from the body through exhalation. It's FDA approved, EMA approved, GMP approved. There's no issues with it at all. You actually consume more CO2 through drinking a carbonated beverage than you will ever consume through consuming concentrates or edibles made with CO2 extract. Next is safety. CO2 presents very low risk to employees and facility. However, there is some confusion in that a lot of people think that with the high pressures you're dealing with a lot more risk. And while in some cases that is correct, our equipment is designed to meet all of the ASME and PED standards here in Europe and the United States and across the world, and those standards and those design practices are created that way for safety. They're overkill in many regards, but safety is very important to everyone. You know, we don't want anybody to get hurt using a piece of equipment. Beyond that, the only other potential concern with CO2 is risk of asphyxiation as it depletes oxygen in the air, and that too is also not very large of a risk. So, as it says here, I don't know if you can read it. Yeah, atmospheric CO2 is roughly 400 to 500 parts per million. According to the United States government agency of OSHA, Occupational Safety and Health Administration, there's a maximum limit of 30,000 ppm, which is actually incredibly high, and they give you 30 minutes to work in that. And so the moment your alarm goes off, which most alarms are set at around 8,000 ppm, you have plenty of time to exit the facility if there is any issue with decompression. The additional benefits to CO2 are the solvent cost. CO2 is very inexpensive compared to other solvents. The availability, it's all over the place. It's a byproduct of many commercial processes. So it's not generally produced to create CO2. It's recaptured from other industries and doesn't really add to the carbon footprint in most cases. Ease of storage. You don't have to deal with issues related to fire departments or municipality concerns around that, because it's a high pressure storage system that has very little chance for leakage. You have 50, 100, 200 pound tanks that don't leak, and you can stack many of them next to each other. They don't degrade over time. They can sit there. With our machines, we can recover anywhere from 80 to 95% of the CO2 used in the process. It depends on your application and what you're using the machine for. So some differences as it relates to the versatility, which was the last item on that previous page, was its selectability and versatility. So with CO2, it has an advantage because you can have multiple states of matter with it. You can be running supercritical CO2, you can be running high pressure liquid CO2, you can be running a gas if you're trying to dry something. Liquid CO2, which is also known as subcritical CO2, a lot of people get that mixed up, is beneficial for certain applications where you want to have very low wax carry through. It generally, it occurs below 31.1 C, so it's a cold process. You're not going to pull through chlorophyll. You're not going to pull through heavy waxes. There's a chance for some to come through, but not much. And you have to be above about 5.1 bar, so somewhere between about a 5.5 bar and really up to 5,000 psi. Provided you're below 30 C, you can be a liquid and be very high density and have a very good extraction from that. The triple point of CO2, which is where it transitions from a liquid or gas to a supercritical fluid, is almost right at 31.1 C. We don't recommend anybody runs close to that, because when you're really close to the triple point, you can change a half a bar and flash from a supercritical fluid to a very low density gas and back and forth, and it causes real problems with the quality of your extract. So we recommend people stay away from that phase change point. So if you're running a liquid CO2, we recommend staying below 30 C and keeping the pressure somewhere below about 1,300 psi. The benefits of liquid CO2 is the color and clarity that you'll get out of the extract. It'll be very clean and transparent with low waxes in it, provided it was done correctly. You can create retail-ready extract using this method and our machines as well. So that's a benefit to people who are trying to make vaporizer pens or edibles or tinctures or capsules or something that they don't want to have all the extra equipment to go through winterization or distillation, you can make shelf-ready product right out of our machines running subcritical parameters. Some disadvantages to running liquid CO2 is you can run into solvent channeling, which is where the solvent will take the path of least resistance. So your efficiency can tend to decline when you're running liquid CO2 because it'll move around denser pockets of material, and to get some of our clients actually will do a half extraction, pull the material out, mix it up, put it back in, and do a second extraction just to make sure that they get the most efficient extraction possible while running subcritical. That's only a couple of people, but it is a possibility. Another disadvantage is the speed. Although you have very high density, your volatility is really low because of your low temperature. So the speed is a little bit slower with subcritical, but you can make shelf-ready product right out of the machine, so it's a trade-off of what you're trying to produce and speed. It does generally require decarboxylation of the plant material, and that is essentially heating the material to an adequate point for an adequate amount of time. We usually recommend about, forgive me, Fahrenheit, 250 degrees Fahrenheit for an hour to an hour and a half in an oven. A convection oven is ideal so that you get very good circulation of the air. There are some ovens, forced air ovens, convection ovens that are actually produced specifically for this that we can sell along with our machines in the event that you're interested in that. Yeah, that's kind of it on liquid CO2. The next one that you'd really be using for extraction, vapor is not really beneficial for extraction, but you can do certain things with it. The other phase that is ideal for CO2 is supercritical fluid extraction and supercritical CO2. And due to your higher process temperatures, in order to be supercritical CO2, you have to be hotter than 31.1 degrees Celsius. We recommend not going below 33 because, again, you get right next to that phase change point and have issues with maintaining parameters, and it gets funky in that area. So above 33 degrees Celsius and above 75 bar, the actual point is 74 bar, but again, you want to stay a little ways away from that. So you're about, as long as you're 1100 psi and about 33 degrees Celsius, you will be a supercritical fluid. However, at that parameter, your density is going to be so low that you're probably not going to have a very good extraction. If you wanted to run it for a day, maybe you would get some good oil out of it, but I don't think anybody wants to do that. So with supercritical extraction, that's kind of the starting point. From there, you want to be able to target the compounds or groups of compounds by increasing the temperature and increasing the pressure. By increasing the temperature, you increase the volatility of the specific compound you're trying to extract, but at the same time, you're decreasing the density. So in order to maintain the density required to transfer the compounds into the collection chamber and through the solvent, you have to then increase the pressure to match the temperature. Benefits to supercritical CO2 include speed. It's a lot faster than subcritical CO2 because of the temperatures and the volatility of the compounds. There's no requirement to decarboxylate the material. However, it does still speed up the process if speed is the name of the game you're going for. A lot of times if people are going to make isolate or crystallate, they're just looking to squeeze it as fast as possible without concern of what you get out of it. So decarbing it, not doing a terpene extraction, and turning it all the way up is the best way to go in that scenario. No channeling, not necessarily no channeling, but very low risk of channeling, because supercritical fluid takes on properties of both a gas and a liquid. It expands to the entire extraction chamber, yet has the density of a liquid, and it also has very low surface tension, so it's able to transfer through cells and extract the compounds much easier. Disadvantages to supercritical CO2 is the higher pressure that you have to go to, makes the equipment a little bit more expensive. You have a slightly increased chance for wax content depending on the parameters that you're running. If you're running really hot and you're running at a high pressure, you're probably going to be pulling waxes through, which will require post-processing such as winterization and distillation. The other disadvantages is at those higher temperatures and pressures, your color and clarity of the extract will decrease as you increase the chlorophyll as well as wax content within your crude extract. Some applications of supercritical CO2 is terpenes. So we're able to produce, and our clients are able to produce very, very clean and product-ready terpenes right out of the machine using supercritical parameters at a high temperature but low density. And I'll get into that a little bit later, but that is a very good application for supercritical CO2 and hemp and cannabis extraction. Subcritical is not always ideal for hemp because in general it's grown outdoors and you have higher wax content when it's grown outdoors. You also have lower cannabinoid content when compared to cannabis, so it kind of makes more sense to just run a supercritical run when you're processing hemp, but you can really use it for whatever and play with it and get the products that you want, do some research, do some development, and fine-tune your products with this type of process. So I spoke a little bit about the selectability of CO2 and that you can target groups of compounds. Cannabinoids tend to co-extract, so that it's tough to separate CBD from THC during the extraction process because they're so similar to each other that they kind of come hand in hand. You can start to partition it to give a better product that's easier to post-process, but it's very difficult to get a pure cannabinoid product during the extraction process. It's much easier to take the crude extract and push it through some other equipment to get what you're looking for. So solubility is important. Solubility is basically the ability of a compound to be dissolved in a solvent. And that is obviously important because that is a direct indicator of how quick your extraction is going to be. It determines the solvent's capacity to dissolve and carry the compounds. And what that means is it will also determine the runtime that you need to do. CO2 has a specific capacity at a given pressure, temperature, and a given compound. And if you have more of those compounds in a plant material, you will need to do a longer run on it to be able to extract all of those compounds from it. The solubility can be modified by increasing the density, and the best way to do that is to increase the pressure and decrease the temperature. But as I said before, as you decrease the temperature, you're decreasing the volatility and therefore decreasing the ability for the solvent to actually extract it. So the volatility is very important as well. And the volatility, and when I say volatility, I don't mean it as explosiveness. It's not going to explode because it's volatile. Volatility is basically the best way to describe it is a measure of a compound's ability to evaporate at atmospheric pressures and temperatures. So water is essentially not volatile at all. It will sit there in a cup for quite a long time until it evaporates. CO2 is incredibly volatile because it will never be liquid in a cup. It'll likely flash straight to dry ice before that would ever happen, and from there it will sublimate into gas. And it's really good for post-processing because you don't have to take steps to remove the solvent. It does it itself. It just evaporates right out of it. Sorry, let me make sure I got everything on this page here. Yeah, and the selectivity and selectability of CO2 with solubility, volatility, is the basis for our slogan of extract what you want, leave behind what you don't. When run correctly, you can get non-winterized oil that exceeds the quality of winterized oil from butane or ethanol out of CO2. It's not going to be the first time you turn on the machine, but within a few weeks you can become an expert at running these machines and make amazing product without the use of extra equipment. So I spoke earlier about terpenes. Terpenes are very important for the entourage effect and whole plant phenomena, and I'm a big advocate for that. I think that isolated CBD is missing many links to help people. I think it's an easy way to get to market because you can sell across international lines and state lines within the United States, but it's missing many of the beneficial compounds that really make cannabis and hemp so medically beneficial. So the traditional method for terpene extraction, which would be essential oils, it's the essence of it, it's the flavor, it's what you smell when you open a bag or when you smell a fresh plant. Those are the terpenes. The traditional method of steam distillation is you raise the temperature of the compound past the point of volatility, creating it, essentially boiling the compound using water, and then the water is actually suspending and transferring the compounds into a condensing column where you can then recapture the water, and terpenes are usually on top, and do a separation that way. The problem with steam distillation is it's inefficient. It leaves your plant material soaking wet, which then has to be dried or processed in some way to get the cannabinoids out. And it's a high temperature when you're talking about volatile, delicate compounds. The benefit to targeted CO2 extraction is the temperature is raised just enough to begin the evaporation of the compounds. And then that, in combination with the low density given a high temperature, low pressure, supercritical scenario, the compounds are dissolved with a targeted density and temperature and carried through to the separation chamber, and this retains nearly the original profile of the plant material, and is very clean and very efficient as well. Most of our terpene runs are 30 to 45 minutes per batch. All of our machines scale up, so that's pretty much whether you're running a 5-liter or a 200-liter machine, that would be the same parameters and run times that you would do with that. And the advantages to it, as I briefly said, are quantity, quality, and time. It's much easier to do it through supercritical CO2 extraction than it is through steam distillation. Then you get onto the cannabinoid extraction. That's really the next step. I always recommend doing a terpene extraction first, whether you're going to be removing the material after a terpene extraction and decarbing it, or you will be moving straight into a non-decarb supercritical run. It's very important that you set the parameters for the specific strain and compound you're trying to get. You can, as I said before, you can co-extract CBD and THC at really any parameter, but there are certain parameters that will pull more of the CBD or more of the THC that you're looking for. Targeted CO2 extraction of cannabinoids is a balance between solubility, and which is density and volatility, and as I said before, it's tough to do because increased density allows for the extraction of the heavier compounds. However, the increased volatility increases the speed of the extraction as well. And as you increase the volatility, you decrease the density. So it's a trade-off of where you want to get to. There is something that is called a crossover pressure and crossover temperature, that at some point, once you hit a certain pressure, you can continue to increase the temperature despite the fact that it's decreasing the density, and continue to increase your yields, and that works adversely with the other way as well. The advantages to targeted CO2 extraction is quantity, quality, and time. The other methods that are generally used are ethanol, hydrocarbon. They're very aggressive solvents. They're used in many commercial applications. There is somewhat of a poor market acceptance of those. Ethanol a little less so. Butane definitely. There's a market for all of the products, but especially as you start to go mainstream, there's a stigma around butane that people just don't like hearing it's in their product. Ethanol as well. Talking with most of the large-scale hemp producers who have tried the whole range of it, the ones who are using ethanol still simply don't want to invest the money into the CO2. If it was a lower price, they would absolutely switch. They just don't want to have the investment cost in it. I had a good conversation with somebody yesterday who I've been in communication with for almost 7 years in Colorado in the hemp industry. And they started out with CO2 in the early stages and moved to a blended hydrocarbon of butane and propane. And that was short-lived. I believe it was about 9 months. And then they switched to ethanol because it could be scaled up much larger. And here we are 2 years later after they switched to ethanol, and they're moving forward with one of the largest CO2 processing facilities in Colorado. So they've come full circle back to CO2, and it's just very good anecdotal evidence of the quality of product you get out of CO2 extraction. Sorry, that slide wasn't supposed to be there. So that's kind of CO2 extraction in a nutshell. Moving on to kind of I.E.S. and our company and what we can provide. I.E.S. technology, one of our key advantages that we have is our automation. We maintain one of the best consistent process conditions. When you look at the graphs of the pressure and temperature throughout the entire run, it's usually plus or minus less than 1 degree Celsius and plus or minus about a half a bar through the entire process, unless there's something mechanical that goes wrong that the programming can't fix. And that's really key, especially if you're running for a shelf-ready product, to be able to accomplish that, because if you don't, you're going to wind up with a crude extract that needs post-processing, such as winterization or distillation. With our machines, they're ergonomic and a very sleek style. We get a lot of comments of how simple it looks. There's not a lot of tubing and stuff on the front side and confusing valves. Everything's automated and hit on the back. It's got a small footprint. Quick access closures and fittings makes changeover, loading, and processing very easy. And process and resource efficiency. We switched from, well, let me back up a sec. We believe in gas compressor style pumps. We think it's unnecessary to turn it to a liquid in order to pump it through the machine and then back to a supercritical fluid and then to a gas to drop out the compounds and then back to a liquid back before the pump. It's electrically inefficient, and gas compressors that work are the best way to go. Up until about a year ago, we were utilizing some high-quality German-built gas booster pumps that were driven by pneumatics, compressed air, and there's a lot of problems with compressing air. Number one, it's incredibly inefficient. You waste a lot of energy to heat, and you have to put way more electricity and power into it to get the same output that what we now use is hydraulically driven gas compression systems. And we wound up producing our own gas compressors and hydraulic power units that go along with our machines. One of the problems with using a third-party manufacturer of the pumps is we're stuck with their design. We're stuck with their warranty system. We're stuck with their seals. And it makes it very difficult to help our customers and service the equipment that we sold them in the field. We wound up having to go back to the manufacturer, and it can have delays in production. And we understand how much money these machines are creating for our clients every day. So every hour that it's down, we are working to get it back up. And if we produce the equipment, we can do it that much easier ourselves. We also have a unique separation and expansion system that we've termed as automated Venturi expansion. And we have the ability with our machines to set the solvent pressure and temperature as well as the separation or expansion pressure and temperature, which is another way to maximize the throughput. On a previous slide, I didn't add the information which I had, is volatility, density, and solvent flow rate or speed are really the three components to achieving a perfect output. And that comes up now because you can control the speed or flow rate of gas through the system even with a fixed displacement pump by decreasing the pressure in the expansion or separation column and thereby giving less gas to the pump every time it takes a breath. So you can control the amount of CO2 that's moving through it, what is called reactor space velocity of the CO2 moving through it, and the residence time, and really start to target what you want. Also, as you decrease the expansion pressure and increase the expansion temperature, you increase the precipitation of the compounds out of the gas during the extraction process. Those are kind of our key features for our machines, and in conjunction with service are really what our customers love. So certified equipment. We currently offer 6 standard models. We used to offer 20 models, and while we still do offer those configurations, they are not standards. There are longer lead times on them. After 5 years of commercially producing systems, we came to know the most common models produced, so we pulled back our offering to match what the customers were interested in. So we have 6 standard models, from a 2x5 liter to a 2x200 liter machine, and we work hand in hand with our clients to determine what they need and what their requirements are to extract their harvest. Additionally, all of our machines are engineered and built to specific standards which are required by our clients. In the United States, we are ETL and UL listed, as well as certified by a third-party engineering peer review company called PSI. They're kind of the standard in the United States right now. They work with all the local municipalities to provide the engineering documentation on the back end as a third party to certify it with fire departments. It's kind of interesting in the U.S., being from Colorado, which was one of the first states to really push the regulations onto the market. The fire department really didn't know what they were doing. We found ourselves essentially teaching the fire department and the municipalities how to regulate us meaning our clients in the industry, using our equipment. So it was beneficial in that we could eliminate concerns or misconceptions, but at the same time it was tricky because we didn't want to give them too much information to come back and over-regulate what we were doing. Team I.E.S. I'm very proud of the team that we have built over the last 6 years. Over the last year, we've almost doubled in growth with employees, and everybody is happy to be there. Everybody's proud to work for the company and to build the brand and service our clients. Our service technicians and engineering team are top-notch. The preventative maintenance programs that we provide are really helpful for our clients to ensure that there is no downtime. There are no guarantees, but with our preventative maintenance programs and service intervals, the goal is to keep the machine running outside of scheduled maintenance times. Client relations and support. As I said, we're very committed to the success of our clients. We're not happy if the machines aren't running. We're not going to walk away from anybody, no matter how difficult the conversation is, no matter what is going on with the machine. We are there to support everybody with the process and with our equipment. On-site training is included with the equipment in the United States, depending on where people are located. We'll do a 2 to 3 day training. We'll come out and ensure the equipment is, it's a training / commissioning. We'll come out and ensure that the equipment is set up correctly. Prior to that, we'll work with engineers and contractors to make sure that everything should be set up correctly, but we double check that when we get there. And provided there's plant material to be run, we will do live runs with our clients. We'll do, starting out with a terpene run, we'll move into a cannabinoid extraction run, then we'll do a clean run, and then we'll start it all over again until we leave. In Europe and internationally, we will do a 2 to 3 week training program to ensure that there's no questions or confusion around the process and operation of the equipment. We also offer certification courses at our facility in Louisville, Colorado. Right now we offer just one level of training, and that's a 2-day course. You get a certificate afterwards. There's many municipalities in the United States that require the operators to be certified by the manufacturer, so that kind of triggered us to do it. But it's been interesting because we find a lot of people contacting us and coming to the trainings and certification courses that are just trying to get into the industry and learn how to use the equipment and then use it as a resume builder to go get a job within the industry. This is a picture of some of our common machines. At the top, that is a 2x5 liter double fraction machine. I'll go over some of the benefits of that. These are the extraction columns right here. You have pressure relief valves and pressure monitoring static devices on it, as well as controlled by the touch screen. We have constant data recording. We keep a log of all of the parameters through the entire run every 2 seconds. So we can forensically go in remotely and determine what's going on or what the likely cause of the issue is and get the equipment fixed and operational faster that way. With these machines, you can run one, the other, or both of them in parallel. They don't run in series. That's kind of just a waste of time. The benefit to that is you can run smaller batches. We don't really recommend going below about 1/3 of the capacity on any machine. And capacity of these machines, that's a good question that we get a lot too, is what can you fit in there? We have some people that put flour directly into the extractor because they think they're going to get a cleaner extraction out of it. And while they may get a very clean looking extraction, they get almost no yield, and then they wind up calling us wondering what's going on. And surface area, especially with CO2 extraction, is very important. So it's beneficial to process the material down to a small particle size, but without going too far. If you go too far, it kind of just turns into a paste in the bottom and you don't get very good flow rate and the system has a hard time balancing. You can fit approximately 1/4 kilo per liter. So a 5 liter would fit 1.25 kilos in it. A double 5 or a 10 liter would be about 2.5 kilos in it. These are the separation/expansion columns. They are separated, and that's primarily due to the requirement to keep the terpenes very clean during extraction. When you switch back and forth between terpenes and cannabinoids, the cannabinoids are much thicker than the terpenes, and if you want to get a very, very, very clean terpene, even if you're running the same botanical over and over again, you want to keep it in one column. Otherwise, you get carryover of cannabinoids because the terpenes themselves act as a solvent in the heat exchangers and will pull through any material that's remaining in there. So if you have a single fraction, like this machine here, that is a single fraction 2x50 liter. And that particular client, that machine is located in Southern California. That particular client, they don't do terpenes. They just go for the fastest pull that they can possibly get and pull it out, do winterization, go through distillation. And they don't do terpenes because they do flavored cartridges. So they'll flavor it with lemon or blueberry, or I think one of them was like Skittles or something like that. It was very, very odd. But there's a market for it. So that would be the benefit of that, is it's slightly less cost. This particular machine right here is a 2x5 triple fraction machine. This person was very interested in getting a terpene extraction, a oil extraction for cannabinoids, and a heavy pull of waxes and residual compounds to be used as a precursor for topicals. So there is added benefit to that third fraction. For the people who don't have triple fraction machines and want to get that product, they will simply set the programming to pause after the cannabinoid run, decompress the separation column, remove the isolation cup, put a new one on, and then go into stage 3 run or whatever it may be to do a higher temperature, higher pressure pull to squeeze the last residual waxes and plant fats out. I think that's pretty much everything that I have on that, and I'd like to start taking some questions if anybody's got any.
Thank you for your presentation, first of all. In case of spare part needs, how soon we can have them in Greece? Thank you for your presentation. In case of spare part needs, how soon can we have them in our area?
So with our international clients, we do a inventory stocking program where we keep critical components on site at their facility in the event that it fails. While we're out there, we train them on how to replace those components, and then that faulty device, whatever it may be, usually a valve, will be sent back and we'll replace it with another one that's on the shelf. Along with that, we try to schedule at least one on-site maintenance for our service technicians to come out and really work the machine over and get it kind of back to as new condition at the end of every year.
Hello, I have a question over the process. When you cut the flour in small parts, you put them in the extractor right away, or you have to distillate first?
No, you put it into the extractor first.
Okay.
With CO2, the ideal condition is as dry as possible. So there is a drying process that you have to do ahead of time. And we also recommend not processing the material, grinding it until it is dried. It becomes very messy when you do it wet. So.
Okay, thanks.
Yeah.
Έχω μια ερώτηση για το κόστος. Okay. Έχω μια ερώτηση για το κόστος. Πόσο στοιχίζει ένα τέτοιο μηχάνημα. Λίγο για τον όγκο σε μέγεθος. Και μου είπε ένας φίλος εχθές ότι μπορεί να κάνεις ταυτόχρονα διάφορες δουλειές. Ας πούμε, δεν ασχολείσαι με καναβινοειδή, του βάζεις ελιές και βγάζει λάδι.
Yes, so our equipment is designed as extraction equipment. It happens to work really well for cannabinoids and terpenes, but you can put just about anything in it. You can extract lavender, you can extract turmeric, you can extract ginger. We've done a lot of stuff in our lab in Colorado, and we actually have a couple people who are dedicated to doing that, and we're going to have a line of videos coming out about those processes just as an educational piece. As it relates to size and cost, obviously size determines the cost of the machine. This is a 2x5 liter double fraction. That's our smallest standard unit. I believe that one is approximately $135 US. Going up to a this is actually not a standard unit. Our standard unit is a 2x50 double fraction machine, and that one I believe is $550,000 US. And we go all the way up to a 2x200 double fraction machine, which you could fit approximately, what is that, 100 kilos per run in it, and that one is 1.45 million US.
Hello from me too. Thank you for your great presentation, first of all. I'm a PhD student, and my thesis is about encapsulation of cannabinoids. So, from what I've read, and sorry if I'm wrong, I believe that the quality of an extraction, it's also it also depends from the plant itself. So I want to ask if there is a possibility to produce an extraction with a certain concentration and certain bioactive compounds in it.
I think you're kind of asking about targeted molecular extraction, being able to precisely pull specific compounds. Well, it is possible. As I said before, it is difficult because of the very close molecular size of the compounds themselves. The co-extraction, if you're going for CBD, you're going to get some THC in it. There is ways to design the equipment to prevent that from happening, but the problem is the cost goes way up. So it's as of right now, it's more cost effective to do a crude extraction and then go through a separation process of winterization if necessary, distillation, and then even chromatography separation.
Okay, thank you.
Yes.
Hi. How much months do you need to deliver after the order?
I'm sorry,
In
what?
Greece, how much months do you need? How many months do you need to deliver in Greece after the order of one machine?
So our current lead time based on orders is approximately 12 weeks to produce any machine that's 2x20 liters and smaller. 2x50 liters and up starts at 6 months and moves up to 8 months on the 2x200s. The vessels themselves are incredibly expensive and take a long time to produce. So it's kind of, once you get into that commercial scale, we build to order. And then shipping is kind of determined based on shipping.
Thanks for the presentation. So just one question for a friend in agriculture, actually, because I'm not the expert here. But he was asking what will be the best equipment for big-scale CO2 extraction?
The best equipment.
Yeah.
I mean, I would say I.E.S. would be my go-to.
I mean, from your side. Yeah.
I don't personally have a lot of experience running other large-scale equipment. All of my experience with other equipment is in the 20 liters and smaller scale. So it's hard for me to really answer that accurately.
Thank you.
Thanks for the presentation. Possibly putting that in a different way, on a grow-out facility of about 10 acres, which in Greece would be 40 square meter, which is a sort of average, what equipment would be equivalent to I.E.S?
So how much can a machine process is probably one of the more complicated questions that we get. Not as far as difficulty to answer, it's difficult to get all the information required to answer that. So, you know, what is an estimated cannabinoid content? What is your estimated yield off of that acreage? That all goes into what size system you need. If you're getting roughly 10% cannabinoid content, and forgive me for using pounds, but and maybe 2,000 pounds per acre, you should be able to process around 100 to 125 acres a year with a 2x200 liter machine.
Just also, your certification program that you have there, is that run at specific times of the year, or someone can book in and?
We do 2 certification classes a month right now. We're going to be probably increasing that to 1 a week. And then we're also going to be adding a second level class that goes a little bit deeper into some of the stuff that I was talking about.
Έχουμε άλλες ερωτήσεις? You're okay?
Yeah.
Okay. Thank you very much.
Thank you, everyone.